All right, I guess I'll get started. Feel free to come in if there anyone's not having a seat yet. Welcome to the Spring Framework talk today. I have the pleasure of returning to Voxxed Vienna, so this is not the first Spring Framework 5 talk I'm giving. I had a kind of preview themes and trends talk last year. So I chose to pick a different focus for this year's talk. This is a somewhat more specialized talk that actually came out of our Spring One platform conference, which happened in December in San Francisco last year. So it's, if I'm not mistaken, literally the second time I'm giving this talk, first time at Spring One last year. With a more specialized focus on the JDK story in Spring Framework 5, the specific arrangements that we're making for Spring Framework 5 to be a fully and truly and deeply Java 8 based framework, and the measures that we're taking towards JDK 9 compatibility. And not only 9, I mean it says 8 and 9 here, but whenever I say 9 in the context of this talk, I really mean 9 plus. I mean, I will elaborate on this and the specifics of 9, 10, 11 a little bit later on. But in the end, every time we say 9 here, we really mean 9 and its follow-ups, 10 and 11. We'll get to that. So Spring Framework 5 itself, let's go to the fact sheet for a moment, is already the 5th major generation that I have the pleasure to introduce. Since I've been doing this since the very inception of the Spring Framework open source project, this is always a very personal milestone as well, to bring a new major generation of the core framework out into the world. And this is kind of the fact sheet, right? We're not going to talk about all of those things in detail, but Spring Framework 5 is many things. The JDK 8 baseline upgrade is one of the key efforts in Spring Framework 5. Another one is the Kotlin focus, so the kind of parallel support for parallel first class support for Kotlin as an implementation language in application projects. So it's essentially Java 8, the language, and it is Kotlin, and it still is groovy. Admittedly, the primary focus is on Java 8 and Kotlin these days, and we really mean those things. So first class support means throughout the framework, Kotlin idiomatic extensions for many Spring Framework API types, just like the Java 8 story. I'll add a few notes to that later on. There is also a key kind of thematic background to Spring Framework 5. We're trying to revisit what we're doing from a different perspective. I'll elaborate on that a bit. And the main part for our purposes today is about the baseline upgrade. It's not just JDK 8 plus, it's also raising the baseline, for example, to Servlet 3.1 plus and JPA 2.1 plus, so kind of drawing a line in terms of how far back we would support integration APIs for external infrastructure. And of course, there's the opportunity not only to kind of raise the minimum level, but to also look towards the very current level. And that is, of course, in the JDK world, it's JDK 9, 10, 11. But in the Java EE world, it is the Java EE 8 API level, which after a somewhat, lengthy and complex process, finally was released to the world last year. And it is the baseline for what is now to become Jakarta EE in the EE4J project. It's the same API level in the end. No real work happened since Java EE 8 yet. So this is Servlet 4.0, it's been validation 2.0, or in terms of providers, it is the recently released Tomcat 9, it is Hibernate Validator 6, it is Hibernate ORM 5.3, which is not actually GA yet. It's the API level behind those providers. There's also first class support for that. So in Spring Framework 5, as usual, kind of, we are trying to position it for the years to come. The baseline is kind of 2013, 2014 era APIs, But what we really care about is the APIs that are going to be mainstream in the course of this year, in the course of next year. So we are really preparing the framework for 2018 and higher. A few words before we go into the JDK topic specifically, a few words on the usage style and the interaction style with the framework components. Spring traditionally has a very strong focus on an annotation-based component model. This is, of course, well established. It's very complete. It's in many ways a totally mainstream programming model in the meantime. This is, of course, fine. I mean, this was a key goal, in particular in the Spring Framework 3 and 4 generation. In Spring Framework 5, we intentionally put ourselves into a different perspective. Take this with a grain of salt. We're not saying that the usage model has to change. The annotation model is still the first kind of first choice, the common choice, the mainstream choice by far. But for the purposes of challenging ourselves, of enforcing a different perspective onto the framework, making the framework usable from different perspectives, we revisited a totally different style, a functional, programmatically oriented functional API style. So instead of using annotations and instead of using reflection, we're trying to programmatically express ourselves, to allow applications, even very minimal microservice arrangements, to express exactly what they need to express in a purely programmatic fashion, with no annotations, no classpath scanning, and to some degree, even no reflection, if you are trying to avoid that to begin with. There's there's many factors that come into play here. Not least of it all Kotlin. So I'll get back to Kotlin here for once, since the Kotlin language provides some very nice facilities. Actually, not the language, but the Kotlin compiler and the runtime provide us with certain introspection mechanisms that allow for closer interaction with the language constructs. For example, we can reliably infer the return type of a Kotlin function, something you cannot do against the Java 8 Lambda expression at runtime. This actually does influence the API design. We can come up with more concise and more expressive Kotlin variants of some APIs because of those runtime features. But back to the notion of functional registration and functional composition. This is, of course, a somewhat extreme perspective. Spring is always about shades of gray, right? A certain middle ground that is emerging, which is what people actually do in practice. Of course, these things mix and match. You can register certain bins programmatically with the functional registration mechanisms, and send the container onto a classpath scan for certain components that you detect by annotation in the classpath, ending up in the same Spring application context eventually. There's nothing wrong with that at all. Those things mix and match. You can programmatically register components that use annotation-based declarative transactions. So all of those things go together. But from a framework design perspective, it is really useful, really healthy to force the framework to be perfectly usable in, for example, even a Kotlin-based programmatic registration scenario that has nothing to do with annotation and even nothing to do with Java the language. The outcome, the common ground underneath, is what is Spring Framework 5 now, and what is really kind of the shaping up that we did towards Spring Framework 5. All right. And even if it's not the focus of today's talk, I have to mention it, of course, because it is one of the things we spent a lot of time on, that we really proudly present to the world in Spring Framework 5, is the reactive programming model and the parallel web stack next to Spring Web MVC, which runs on the Servlet API. We have a parallel web framework called Spring Web Flux, which is a reactive streams-based web framework all the way through. This on its own is, of course, a very, very key topic and a very broad topic, which is not the focus of today's talk. But of course, a key reason why Spring Framework 5 really makes quite an impact onto the Java scene at the moment. Just clarifying one essential piece here, and I already hinted at it. Those are two web stacks. Spring Framework 5 comes with two web stacks, of course aligned with common ground underneath, but essentially two web frameworks next to each other. Spring Web MVC being a servlet API-based framework as you know it, allowing for straightforward upgrades from a Spring Framework 4 to 5. It's basically the same stack. It's still servlet API-based, does everything it did before, has some fine-tuned contracts underneath, but you probably won't even notice. Many extensions still run. The usage model, typically annotation-based, is still the same. So a very straightforward upgrade path, in particular for existing web applications, but also for newly written applications where the servlet world is the best possible match and totally fine, right? Servlets, of course, come with certain limitations from the servlet abstraction, a thread per request, kind of thread-bound processing. This is a limitation and a quality at the same time. There are many things that you can easily do in a servlet-based stack here that you cannot do in a reactive stack. So this is not a black and white choice, and it's not like backwards compatibility and here's the new thing, the shiny new thing. It's really two options with their own qualities and their own benefits and drawbacks. And it's your choice for a newly started Spring Framework 5 based or Spring Boot 2 based web project. It's your choice of web framework, right? So like traditional blocking, JPA, JDBC, API, transaction per thread, thread-bound transactions, you're probably better off here on Spring Framework 5, no doubt about it. If you got a reactive database driver for Couchbase, for Cassandra, for MongoDB, and you'd like to expose the reactive interaction model that the data store is offering to a web stack, to a Spring-based web stack, then Webflux is your friend. Your choice of underlying HTTP engine, not servlet-based, reactive streams-based. Even if Tomcat and Jetty are used as an engine underneath the covers, they don't serve as a servlet container here. They serve as a reactive streams-enabled HTTP engine. And so it's really a reactive power that can be exposed to the web endpoints and two usage models on top. An annotation-based model, even for the reactive stack, and a programmatic functionally oriented model for the reactive stack. All right, so much really for, we'll get back to certain parts of this, but so much for the kind of general Spring Framework 5 storyline. A key and often underappreciated step that we took in Spring Framework 5 is the JDK 8 baseline upgrade. This is the first time we actually do this, that the entire framework is Java 8 based. And it's worth reiterating why it comes so late, right? It's not really late, but for our purposes, it's sort of late that we go that far. The main reason is quite simple. In Spring Framework 4, let's take for the 3 as the end of that line. In Spring Framework 4.3, there is already a very rich Java 8 development experience for applications. It's internally a Java 6-based framework with many Java 8 extensions that are automatically enabled and live in these standard jars. So from a usage perspective, if you consume Spring Framework 4.3 in a Java 8-based application setup, it essentially feels like a Java 8-based framework to you. At least in many ways, right? For many scenarios. But there are certain things we cannot do, or certain things that we have to do in a specific fashion, right? If you present code to us, annotation-based components with injection points, with handler method parameters, then we can reflectively introspect the use of Java 8 constructs. We can see that you're using Java util optional, and we can automatically create an optional instance for you. We can detect your usage of completable future. We can understand what you mean if you're trying to bind an HTTP header to a kind of local date or whatever. Right? So we do all of this reflectively through Java 8 extensions, essentially, that are reflectively enabled. It's quite efficient at runtime. There's no performance drawback, but it is something we can only provide to your code. The framework itself, the framework APIs and the framework code base, the implementation code base, cannot make use of Java 8 constructs. So this, in Folder 3, we even go a little bit further, and it's worth pointing out that this notion of functional interfaces in Java 8 was really, it really comes with a fine convention-based design. We can very easily interact with Lambda expressions and method references without having to declare any specific Java 8 constructs, because it's a convention. An interface with a single callback method can serve as a functional interface. The Java 8 compiler accepts that sort of interface as the target of a Lambda expression or a method reference, without an functional interface annotation or any other Java 8 specific construct. So even quite elaborate use of Java 8 constructs in your code against Spring APIs is already possible in Spring Framework 4.3. We're even using repeatable annotations by declaring the convention for repeatable annotations. It's a Java 8 feature, Java 8 compiler feature that we already enable for quite a few annotations in Spring Framework 4.3. If you're using the Java 8 compiler, if you're using Java 6 or 7, you have to do it the old style way with a container annotation. But it's kind of naturally ignored. There's no parallel existence of distinct Java 8 code and pre-Java 8 code here. It's the same code base, the same framework, the same jars, automatically adapting to your use of Spring Framework 4.3 on Java 8 versus Java 7 or 6. This is the main reason why the Java 8 story is already in place in action for several years. Right? It's against Spring Framework 4.3. But we were waiting for a certain point of time. And that point of time came in the second half of last year. Java 8 becoming dominant in the industry, not just being the stuff that kind of the latest projects use, that newly started projects use, but Java 8 as a baseline even for existing deployment environments, even for existing data centers. This is, of course, it comes out of a survey, but it's quite indicative and quite accurate, I believe, indicating a strong dominance of Java 8 late last year. This is really the point that we were waiting for, where it makes sense for the framework itself not only to support Java 8 in a broad and deep fashion, but also to be Java 8 based internally and really embracing even the little things we can do with Java 8. So Spring Framework 5 is Java 8 based now, requires Java 8. If you're on 6 or 7, there's always Spring Framework 4.3 for you, and it's going to be supported for several years to come, right? So it's not going away all that quickly. But in Spring Framework 5, we literally revisited the entire code base. I'm not entirely sure that we touched every source file, but certainly very many of those. Just by iteratively using Java 8 constructs internally. We of course have plenty of code that can benefit in terms of its readability, in terms of its maintainability from the use of Java 8 constructs internally. Like all the collection interactions, right? We can choose to use collection streams. We can choose to use the new operations on collection and map. We can use for each with a consumer callback. We can do all of those really nice things that you may already be totally used to in your application code. We can finally do them internally in the framework. And there were many iterations, many contributions also from the community in terms of how to improve the existing code base along those lines. There's also some new runtime facilities in Java 8 that allow for doing things somewhat more efficiently than before, in particular in the reflection APIs, in parameter reflection. So this is nice, of course. Won't make much difference in practice, but it certainly is a step forward. We're really taking it that far, right? We're doing everything we can to kind of exploit what Java 8 is offering within our framework code base. More importantly, maybe for application purposes, right? We can start exposing Java 8 specific API types, new API types that have been introduced in Java 8, we can finally expose them in our core framework APIs. Simply speaking, right? Framework interfaces like Bean Factory, like application context and others previously were unable to have hard references to Java 8 API types. No completable future, no Java time types, no Java util optional, no Java util collection streams. In the hard interfaces, right? We were only able to reflectively support them in your code if you wanted an incoming parameter of that kind or you had a return value of that kind. But we couldn't do this in the core framework APIs because they had to be runtime compatible with 6 and 7. We're finally able to do this. And this is one of the most significant revision in the APIs, that there are some overloaded methods now that instead of a Java util date, they may take a Java time instant. They accept a Java time duration parameter where that is semantically applicable. We have hard conversion APIs, very immediate convenient conversion APIs between listenable future and completable future. And we're making use of the Java util function interfaces. This is maybe the most important common ground in terms of API design in Java 8. Finally, we have a quite rich set of functional interfaces, of simple common callback interfaces that everybody is using already, but all in their own little copies. Now we have kind of a canonical version in the Java util function packages of Java 8. And we're making quite some use of this. The notion of instance suppliers, the notion of dependency consumers. There are quite a few Spring APIs that expose or accept callbacks of this kind now. And on the way forward, we're trying to make as much use as possible of those common core Java 8 callback APIs, callback interfaces, instead of inventing our own. Right, and one of the goals here is not just to do it because we can. There's also some interoperability behind this, because quite a few libraries and frameworks out there are already Java 8 based, or at least have Java 8 based versions of themselves. And of course, they would use those Java 8 constructs. They use Java util function. They accept Java util function parameters. They return completable futures. They use the Java.time types. If you wanted to programmatically interact with them from a Spring Container background, a Spring Container context, to those Java 8 based APIs, it of course is really useful if they kind of talk the same language and they use the same API types without any need for adaptation or for conversion. So not least of it all for that reason, we're trying to streamline the entire API surface in Spring towards the common API design ground in Java 8. So just a few examples so that you also got some names, right? On those slides. I'll elaborate a bit on the whys here. Another one is default methods in Java 8. This is a language feature allowing for an interface to have a method declaration with a body, right? So in Java 8, an interface doesn't have to have abstract method declarations. It can choose to have default methods with a simple default implementation. Of course, no state attached, but the default implementation may call other methods on the interface, or it may throw unsupported operation exception, but at least it's there. It's there for it to be compiled against. It's primarily a language feature that they introduced to allow smooth migration of interfaces. Adding additional methods to existing interfaces is otherwise always painful, because an existing implementation of that interface doesn't have those new methods. So it would fail whenever those new methods are being used. Default methods are a way to suggest default implementations for some of those new methods in the interface, so that existing implementations would implicitly get those new methods as well in their default incarnation. We're making quite some use of this in Spring Framework 5. And essentially for two different reasons. There are quite a few cases where we provide convenience methods along those lines, basically overloads where just there's a very simple default implementation calling some other method on the same interface with some adaptive parameter or some missing parameter, right? So that's an easy way to introduce those is through default methods. So we're not just using it for a backwards compatibility story, we are using it as a design measure, as a design tool in our interfaces. Quite a few existing methods have been turned into default methods. That maybe needs a little bit of extra elaboration. So there are existing methods in the Spring framework interfaces now declared as default. It's simply for convenience. If you implement, for example, the bean post-processor interface, it has 2 callback methods. In all likelihood, you're probably only interested in one of the 2. But you always had to implement 2 in traditional Java. Now in bean post-processor, both of those have been declared as default. They basically return the bean as is in their default implementation. So whenever you implement the bean post-processor interface, you choose to just overwrite one of the 2, the one where you actually want to customize. So default methods are also a way to conveniently get rid of kind of stub implementations for certain interface methods that you don't care about. This is a quite important use of default methods in its own right. Not having nothing to do with backwards compatibility, but instead having to do with convenience for implementers of certain callback APIs with more than one method, usually. We exploit this quite a bit in bean post-processor. Factory bean has default implementations for like a singleton. We even have some default implementations in SPIs, like in the resource SPI. This is actually quite useful as a kind of design tool for us. But in particular, it makes it easier also for the backwards compatibility aspect for us to introduce new methods along the same lines. The new methods are also default. They do provide for this feature that existing implementations inherit that new method, but design-wise, they are then also aligned with existing methods that are declared as default the same style, right? We care about consistency. There shouldn't be an artificial difference between newly declared methods, newly added methods, and existing methods. If they are of the same kind, and both of them benefit from a default declaration, then they have it now in Spring Framework 5. Maybe the most common ones are to be found in the integration at higher levels. The transaction synchronization callback interface, plenty of methods, benefits greatly from default declarations for those existing methods. Or in Spring MVC, the handler interceptor with 3 callback methods, and in all likelihood, you may be interested in 1 or 2 of them, but not in all 3. More convenient to implement now. And no need for adapter classes anymore with stub implementations of the other methods. So this is, of course, also something you may exploit in your own library or framework design if you have certain parts of your code base that fall into that category. Okay, now back to a slightly higher usage level. How would we use this? For example, for the programmatic registration part, this is how you would be able to write code with Java 8 now in Spring Framework 5. Generic application context is the same class that existed ever since Spring Framework 2.5. Basically, just say new application context, this is your container instance now. And instead of sending it onto a classpath scan or registering annotation-based components, you register beans by class. Beans by class is somewhat easy, right? Also somewhat boring, because in a way you were able to do this before, and we constructed with its default constructor and don't do anything special with it, really. The new part comes with what we call instance suppliers. Here we register a bean of type bar, and we pass a lambda expression in. This is actually a Java util function supplier in terms of its signature. Every time the container needs a new instance of that bean, it actually dispatches to this instance supplier. So whenever the container decides to create a new instance of bar, it won't call the default constructor or any other constructor. It will call this instance supplier, and the job of this supplier is to create a new instance of bar. It's as simple as that. If you need dependencies onto other beans in its simplest possible fashion, just call back to the container and obtain them. There are some existing retrieval methods and some new retrieval variants, and there are some further ones coming in 5.1. for programmatic retrieval, programmatic filtering of existing beans, so that you can programmatically extract them and pass them into the bar constructor, which in this case accepts a foo instance as a dependency. So it's constructor-based dependency injection in a functional style. So no add auto wide here, no class path scanning in this setup. Technically, there's reflection here. So this one calls the default constructor. It basically does class new instance. Technically, it doesn't actually do class new instance, but something along the lines, right? So that's effectively reflection. But this one doesn't use any reflection, because an instance supplier is compiled by the Java 8 compiler as a Lambda expression, basically into a synthetic method on the same class with a direct invoke dynamic dispatch. So whenever the container needs to dispatch to this supplier, it's literally straight into it. There's no reflection in between. If you wanted to exploit this a little bit further, here's a fine-tuned version just to indicate what's possible. This one specifies an instance supplier. Probably it's worth a second look, right? This is a Java 8 method reference, not a Lambda expression, but the method reference also binds to the supplier interface, to the same interface that this one applies to. No overload here. So it's some only very few methods exposed here, but that are very flexibly used with Java 8 language constructs. So what does it actually do? It says, whenever you need a new instance of foo, call foo : new, right? Well, that's the default constructor, right? It's the Java 8 method reference pointing to the default constructor of foo. There is a difference here, because foo itself, because foo here, up here, required a reflection to call its default constructor, and here we bind the method reference to the default constructor, so we have the same invoke dynamic straight dispatch, no reflection involved. So this is just fine-tuning, semantically equivalent, but this is slightly more efficient. Only really makes a difference if you're creating many instances of it, right? So for a prototype bean, for a request scope bean, this may be worth fine-tuning. And it's also to make a point, because you can set up a Spring application context without use of reflection for bean creation purposes. All right, so this one is also slightly fine-tuned. Also exploiting some Java 8 language constructs here. It's actually two arguments, two Lambda expressions, both of them in line. This one is the instance supplier. This one is what we call a bean definition customizer. It's a var arg, so you can have any number of bean definition customizers. So line by line by line. If you want further customization, just comma, next Lambda expression. And it's always the bean definition, which is the internal, it's kind of the underlying metadata object in the Spring container, being passed in for any remaining customizations. For example, setting the lazy init flag, programmatically adding qualifiers, adding other attributes. There's attribute storage that can be used in post-processors. There's all the things you could always do programmatically against the bean definition can also be conveniently customized here. This, to me, from my perspective, is a fine example of what we're trying to enable here. Some very specific measures in Spring's API design, allowing for some quite flexible, quite clever, I would argue, usage of Java 8 language constructs for Spring configuration purposes. Clever in the sense of making the best possible use of the Java 8 language possibilities, right? We're really not trying to invent anything new here. We're trying to take the features that the Java 8 language compiler comes with, and we're trying to make the best possible use of it in our context, in our world here. There's an equivalent for this in Kotlin, by the way. The focus for a different talk, right? So another example for Java 8 API design brought into Spring practice. This is what we call router functions. So if you remember, in the reactive web stack in Spring Webflux, you could choose to use an annotation-based usage model. You could also choose to go with what this little slide called router functions, and this is what we're seeing here. A programmatic way of tapping into the Webflux stack, the reactive web stack in Spring Framework 5. This may initially look a little bit scary, but don't let it scare you. It's basically standard Java 8 interactions in a fluent style. What are we doing here? We're setting up a router. There's a static input here for router functions. So that's a static method coming from that input. There's also a static input for get, of course. So we're saying we want to express a route for any incoming request that matches this predicate. Please dispatch to this method in order to arrive at a reactive streams publisher for the response to this request. And we actually have two routes. We're saying for this route, dispatch to this handler function. It's actually an interface, a functional interface called handler function. You don't see it because we use an inline Java 8 Lambda code block to express this handler function. Handler function has a server request coming in and the mono of server response going out. But you don't really see the signature, right? You just see the use of the incoming request and you see a server response being returned. There's a second route connected to it in this little, almost a domain-specific language of a kind, right? A DSL of a kind. So for this incoming predicate, pass control or dispatch to this particular handler function here. So maybe let's quickly go into what they are doing, right? So this one is actually quite straightforward. It uses a repository, a target object that we're using here, and this router function, which can, for example, be say a Couchbase bound repository from our Spring Data project, or it could be a custom repository implementation that you hand-coded, returning a reactive streams publisher. And this is exactly what the findAll method is doing. It's returning what we call a flux. Flux and mono are both reactive streams publishers. Flux is basically an open-ended stream of objects, a hot stream of objects, a reactive stream of objects, whereas mono is a single object or none. So it's a little bit like Java util stream and Java util optional. Or if you know RxJava, and this is very close to RxJava in mind, in RxJava, of course, that could be an observable, and this could be a single. So this is basically a handle that is capable of producing this sequence of user objects when actually needed. It's a recipe, right? This does not trigger the actual data store operation. It sets it up, and it can be integrated into a reactive streams pipeline so that whenever we are ready to actually process this, we kick it off and we process the elements as they arrive one by one or in a batch without ever blocking. So a key quality of the API design and the underlying reactive web stack here is that we are never ever blocking. So there's an event loop with just a few threads processing all of those interactions. And here then it's a builder API saying, HTTP OK, this is the body, a publisher for the body, and we have to specify the body element class if we want runtime conversion, for example, to JSON elements. So up here, it's just slightly more elaborate. Maybe some of you already tried to parse it, right? We're basically saying the incoming path has a path variable. Let's extract that path variable. Let's convert it to a long and pass the outcome of that conversion, which is the long ID, to the repository findById method, which is, of course, a Java 8 method reference here that we're binding to. Let's assume there's a findById long ID method right on that repository. And then we're building the server response again for the single user object that we just found by ID. But again, actually, we didn't find it, right? We expressed how to find it. It's a recipe. It's a reactive streams publisher that is capable of loading that object by ID whenever we're ready to process the outcome. Both of those go back, register to the runtime stack. And whenever a request comes in, whenever the request is fully parsed, whenever the response is ready to be written to, then and only then we start triggering those operations. And there's a back pressure model involved in the background. So whenever data arrives, we're kind of sending it through the codec step or rendering it out to the response. Basically, element by element, we never ever block waiting for the next element to come in. We're being notified when the next element is ready to be processed. Back up to our API design perspective here. There's really close interaction between how those APIs are designed, how you need to express yourself here, and how the underlying stack works, right? All right, so much for a little bit of Java 8 usage in the reactive world. We are not the first and not the only open source framework to have a Java 8 baseline these days. There's, for example, JUnit 5, there's our own project Reactor, Hibernate ORM, SO 5.2 and further. They are all coming up basically ready to be Java 8 baseline now because Java 8 is just mainstream. All right, so let's move on and talk about JDK 9 a bit. So in practice, many of the things we do in Spring Framework 5 are Java 8 enabled, Java 8 based, but we look forward towards JDK 9 in many ways. We released a week after JDK 9's GA, and we track JDK 10 and 11 very closely. In JDK 9, there's not that many language features. I mean, there is this new language for module info classes, but the main reason why you would move to JDK 9 is not so much driven by language features. It's more infrastructural. There are many improvements at the JVM level. You could argue basically the JDK itself, the JDK setup, and the runtime infrastructure, the JVM, have been heavily refactored for JDK 9. And we get quite a bit out of this. They really took the time to do this deeply. So at the JVM level, for example, we have compact strings with a more efficient memory representation of strings at runtime if they can be encoded in a single byte. We have the G1 garbage collector by default now. We can build custom JVM distributions, including certain modules and certain characteristics of the JVM only. There are many things we can do finally with the JVM that we are totally not used to doing in Java land. We finally have an SSL stack that's ready for HTTP 2 out of the box without having to append something to the boot class path or to kind of hack into the Java 8 JVM at all. It's kind of that alone is actually a quite key reason why you would want to deploy to Java 9. And of course, there's Jigsaw, the module system. I intentionally put it in that order. I see the JVM improvements and the stack improvements, the security stack improvements as key reasons why you upgrade to JDK 9. Jigsaw, the module system, explicit use of the module system in your application code base is kind of a bonus, and I would not put it any further up because all of the other features in JDK 9 are so worth upgrading to. So don't let Jigsaw and the module system scare you. We also talked about reactive streams already. It's just a side note. Let's skip this quickly. But Java 9 contains a version of the reactive streams SPI that we are using in Spring Framework 5 in a repackaged Java util concurrent flow. And if you use this or any library that are based on this with the Spring Framework 5 reactive web stack, we would naturally understand it. So the reactive streams contract is actually baked into JDK 9, but just the contract. No providers, no implementations, no web server, no database drivers. This is to follow in further generations of the JDK. So we may see some use of this, for example, a reactively enabled database driver coming out of the JDBC group sometime soon. It's in the prototype stage, unclear when it's going to be productized, but the core contract, really just a few interfaces, are already part of the JDK. Other things that at the API level may be worth upgrading to is nice new factory methods for kind of constant sets and lists and maps. So instead of having to manually build this and do an unmodifiable collection in front of it, there's simple convenience methods for constant collections now. And there are a few nice things in the Java util stream and Java util optional APIs that are new in 9, introduced in 8 originally, and some new methods in 9 that really make sense and arguably should have been there in 8 already. So there's quite a bit of new API stuff in JDK 9. We're not going to dive very deeply into this, but all of this forms a reason why you would want to upgrade to it. Now, in Jigsaw in the module system, there is a lot of reworking within the JDK. The JDK internally, the JVM internally, does not look anything like before. Not the directory layout, and not the runtime system either. There is no RTjar anymore. There is a decomposed arrangement of JMod files, efficiently compiled modules that the JVM is loading at runtime on demand. And each of those modules, those JDK modules, has its own name, like java.base, java.sql, java.activation. Those are all separate modules. Java.base is basically lang, util, that sort of stuff, right? But almost anything that they could factor out, they did actually factor out. And you can choose to link it in, for example, in a custom JVM distribution, or you can choose to not activate it at runtime when you bootstrap your JVM and to link in an external dependency instead. Instead of the JXB version that comes with JDK 9, you can choose to use one that comes from Maven Central, and there's no overriding problem. So decomposing the JDK itself into smaller modules that you can choose to use or not use is a totally fine step. It forces libraries and dependencies to revisit their dependency assumptions to some degree, but that's okay. And we've been forced to do this before because Google App Engine has also a much smaller set of default APIs. So it doesn't really do anything to the Spring Framework code base that wasn't necessary before. But there are some other libraries and frameworks that are affected by this because they assume that JXB or Java util logging or even JNDI are present by default, which they are not necessarily on a JDK 9 Plus distribution. So not really something that affects Spring much at all, but if you're building a JDK 9 based stack of other libraries and frameworks, you may hit some of this. Interestingly, even the JavaX annotation package is now not present in java.base anymore. So annotations like resource, post-construct, predestroy are not actually active by default. They are factored out, and you are supposed to use a JavaX annotation distribution from Maven Central instead. A version of your choice, a combination of your choice. And in JDK 11, coming up in September this year, in all likelihood, these deprecated modules are not even going to be there anymore. So you have to get those providers and those APIs from Maven Central. So that's the JDK internal module graph. You see that there's quite a bit of connections. The JDK libraries, of course, are heavily intertwined. They have been growing as a kind of monolithic core library for well, quite some time, right? A few decades. So obviously there are strong interdependencies between those modules, but it's nevertheless very worth having gone through this decomposition step in JDK 9. You may choose to use the same module system for application modules. But if you're doing this, you have kind of a limited perspective onto it. You can't use JMod files. That's a JDK internal, JVM internal format. All you can do is take your jar files, which might already be modularized, and add a module descriptor to it. Enforce certain characteristics, certain separation characteristics in your jar file, and add extra metadata that expresses the relationship to other modules. So basically dependencies on other modules and which packages you'd like to export to other modules. There's a couple of things you cannot do in the module system anymore. So there can't be any cycles between dependencies. There can't be split packages, like the same package in several jar files merged at runtime. There has to be a clean assignment of package to module. But ultimately, this is not rocket science. It's just a formalized version of something you may have been doing before, like separating your code into modules with certain dependencies allowed, others not allowed, certain packages to be used by other modules, others to be considered internal. This is just a formal representation and a way to instruct the JVM to enforce those characteristics at runtime. Whereas on the class path, so if you just drop your jar files onto the class path, which you can keep doing on Java 9, there's no enforcement. It's basically just a long sequence of zip files, and every time we need a class or a resource, we search through that long list, and at some point we find it. That's all we're doing. There's no separation. Whereas on the module path, which is kind of a different mode of operation, so there's kind of, you can bootstrap Java 9 in classpath mode or in module path mode. And if you deploy your jar files in module path mode, each of them is going to be concealed by a runtime shell around it. Every jar kind of has a module representation at runtime. So it's not just a compiler enforcing something, it's also the runtime enforcing something. And there's even reflection APIs to understand those structures at runtime. So for tools, even for frameworks to some degree, we can interact with these runtime representations. We can ask a certain package which module it belongs to. We can introspect the boundaries of a module. So there's a formal representation of the structure of your deployment layout that the JVM and frameworks and tools that run on the JVM can use. There's this notion of the module descriptor is not actually strictly necessary. So a jar file deployed to the module path should have a module descriptor. Alternatively, it can be an automatic module, which is basically a regular jar file, adhering to the constraints, so no split packages, no cycles, but otherwise not having extra metadata with it. And of course, a regular jar file adhering to conventions is great. This is exactly what Spring Framework is doing in order to remain Java 8 compatible. So what we do in Spring Framework 5 basically falls right into this perspective. If you choose to use the module system in Java 9 in your application layout, Spring is ready to be consumed in such a scenario. You may choose to, for example, have a kind of database layer module of yours, and you may say requires spring.jdbc to formally express a relationship to the Spring JDBC module, which is essentially just the Spring JDBC jar as you get it from Maven Central, with a little bit of extra metadata. We ship an automatic module name entry so that the JVM in module path mode has a well-defined module name assigned with each of the jar files. This is just a manifest entry. Otherwise, we export all our packages as we always did. And we get runtime resolution of our interdependencies from the JVM. So Spring JDBC automatically sees Spring TX and Spring Core, for example. You don't have to express this anywhere. The usage model is perfectly fine, and that's essentially what we're focused on. You should be able to do this if you choose to use the module system in your application projects. And as of Spring Framework 5, this is reliably possible. In Spring Framework 4.3, it's also possible if you don't rename the jar files, you can have the same experience. So Spring Framework 4.3 is technically usable in the module system, but it's not actually first class support there quite yet. This little syntax that you're seeing here is the module info file. It's basically like package info, module-info, put it into your jar file, compile it with Java-C, with a Java compiler as usual. It's a little language that allows you to express this is a module name, dependencies and exports. We don't actually ship such module descriptors in the Spring Framework jars, to reiterate that point. All we do is that we have a manifest entry for a stable module name, because Java 9 comes with conventions for the rest, right? The module name needs to be assigned somewhere. It can be derived from the jar file, but if you want a stable name, there's a manifest entry for it. Required dependencies can be resolved automatically at runtime if you want them to. And if you want to export everything, then that's the convention by default, right? And that is the reason why we don't ship module descriptors. For Java 8 compatibility, for allowing the framework to remain buildable on Java 8, this is a great design that they did in Java 9. And there were a few cycles involved here. So we have been involved in the late stages of the Jigsaw design before JDK 9 went live. So we wanted the conventions to match what we are doing here. So we had quite some interaction with the JDK team. And kudos to them for being lenient with those conventions so that we can use them from a Java 8-based framework. It's a little bit like what they did back in Java 8 with Lambda expressions and functional interfaces by convention. This is kind of the same line of thinking, allowing easier migration for existing frameworks and libraries. All right, a specific notion to wrap this up, a specific notion that is worth exploring a little bit because it's often misunderstood. idea of a module concealing internals can be relevant for a framework like Spring, right? What if you want Spring to create certain implementation beans of yours that are otherwise not part of the surface? Whatever you want Spring to create for you and to configure for you needs to be visible, right? So you have to export at least the entry points, at least the factory methods for your implementation types. If all you want Spring to do is to talk to public artifacts, like public classes, public constructors, public methods, there's nothing extra you have to do. But if you want add auto-wired on non-public constructors or non-public fields or non-public methods, you're going to learn quickly that this isn't possible in Jigsaw. It's possible in classpath mode. But if you run in module path mode, you have to open your module accordingly, because modules are concealed by default. Everything that's exported and public is visible to the outside, but only that, right? No non-exported classes, and in particular, no non-public artifacts of the exported classes. So for Spring purposes, an application module does not have to be open if all you want to do is talk to public artifacts, public constructors, and public classes, for example. Spring can happily do this for you without any extra declarations. If you want Spring to see internals, non-public artifacts of your class, you have to export certain packages as open or the entire module as open, all the packages in the module as open. If you're trying this, you'll learn quickly that it's not Spring that you're opening it for. It will be the data binding libraries, Hibernate, Jigsaw. These are the typical candidates that kind of force you to open your module, but usually not Spring's configuration purposes. In any case, there's a solution for this, right? The open keyword is a first-class feature in the Jigsaw module system. All right, so we already are at the end of this little tour. Just a few recommendations and a little bit of a summary. If you want to upgrade, I strongly recommend familiarizing yourself with Java 9 and higher. I mean, at this point, take Java 10 release candidate or wait 2 weeks and take JDK 10 GA. We're getting a new JDK release every half year now, right? So 9 or 10 or 11, whatever the latest is, familiarize yourself with it. Do the smoke test. Run an existing integration test of yours or just an existing setup of yours on the latest JDK and see whether it works. You've got a strong chance of that simply working for Spring-based applications on the JVM class path. Even when you're using Hibernate, even when you're using Jigsaw, this has a high chance of working because all of those libraries have been upgraded to some degree and run fine on Java 9 and higher, at least in class path mode. There's some enforcement in the module path setup that may break some existing libraries. For example, the Netty networking library and or Groovy are still not perfectly usable on the module path, but they are usable on the Java 9 class path. So consider staying on the class path. Basically, take your existing setup, Java 8 based, and just run it on Java 9, 10, or 11. Consider even staying at the Java 8 bytecode level, which basically means keep compiling with target 1.8. This significantly reduces the pain that you're being exposed to, because many existing frameworks and bytecode processing libraries and bytecode processing tools need to understand the bytecode level. And the JDK 9 or 10 or 11 bytecode level might be new to them, right? And actually, 9 has a new bytecode level, 10 has an even newer one, and 11 will get yet another revision. So you'll have that problem every half year. If you just keep compiling with target 1.8, you can use all of the infrastructure in Java 9. You can even use some of the new APIs in Java 9. You cannot use any of the language constructs in Java 9, which is not usually a huge issue unless you want to do modules, right? So keep compiling with target 1.8, deploy to the class path, and you might be a happy user of the new JDK 9 improved runtime, the runtime infrastructure, with a Java 8 based project just deployed to JDK 9, 10 or higher. Right, so just the dates here. This is a quite unusual scenario for us in the Java ecosystem. 9 is basically already end of life thing. will be end of life in 2 weeks. Bye-bye JDK 9, hello JDK 10. But JDK 10 will be end of life in September, in half a year. So if you want to give it a try, do it quickly. Otherwise, you're already in place to give JDK 11 a try. Most importantly, JDK 11 will be a long-term support release. It's a little unclear what exactly that means. From Oracle's perspective, it at the very least means you will be able to buy a support contract from Oracle for it, providing you with maintenance releases until 2025. Whether and how long some of those maintenance releases will be publicly available to the community is yet to be determined. The community is kind of expected to upgrade the JDK every half year. Right, in the Spring Framework setup, we're currently in a position where the framework itself is Java 8 based. It also still builds on Java 8. All the tests run on Java 8. If you just switch Java Home to 9 or 10 and rerun the Spring Framework build as you get it from GitHub, it will still execute, build, and or run all the integration tests. So the build actually works across those 3 JDKs, and in all likelihood, it will also work on JDK 11 even without any extra measures. We had a few measures in place within the framework, making it easier to run on newer JDK generations. Most importantly, if you are courageous enough, daring enough, to give the new bytecode level a try, right? To, for example, use the Java 10 bytecode level because you want to give var, the var keyword, a try. That works fine with Spring because we have some measures in place that leniently accept new bytecode levels. You might have a much harder time with the Hibernates of this world and other libraries with different bytecode generation libraries in place. But from Spring's perspective, all that we can do is we want to put ourselves into a position where existing Spring Framework versions, like Spring Framework 504 or 505, can be used in JDK 10 and 11, even with the newest bytecode levels, without any extra measures. So we are kind of anticipating use of existing framework versions on newer JDK generations already. We're not going to ask you to upgrade to 5.1 just for that purpose. All right, so much for this little, or actually quite extensive story. So in many ways, Spring Framework 5 is our Java 8 very deep embracing release, and a lot of the goodness and many of the things that you will find yourself hopefully appreciating in practice actually comes out of this JDK 8 baseline. As a bonus, you can choose to run it on JDK 9 and try to embrace JDK 9 or 10 or 11. I would only recommend doing this for new language features and new APIs if you have a clear and strong need to do it. Otherwise, consider the arrangement of compile against JDK 8, deploy to 9, 10, or 11. You might have a quite fine experience with this and get lots of runtime benefits out of it. Right, and there are a couple of things that we only touched upon in the course of this presentation. There's plenty of content to be found through Google and YouTube if you are more deeply interested into the reactive story on Spring Framework 5 or the Kotlin story. There are dedicated presentations from some of my colleagues, all available on YouTube if you're interested. So there's many other storylines in Spring Framework 5 that we only touched upon that may be worth exploring on their own right. All right, then thanks for your attention. If there are any questions, I'm happy to take them. Just come up to the stage or catch me out there. We're also very easily reachable. If anything comes up after the fact here, just get in touch with us on the blog, on GitHub, wherever. We are in a stage with Spring Framework 5 where we are very, very interested in how it goes with the practical. How does it go with the practical experiences, right? How does it feel like when you're actually trying to put it into production? If you're trying to use it in anger for solving particular problems, so by all means, let us know and enjoy the rest of the show. There's a closing keynote following. Thanks.